Okay, some log problems. First thing we want to do is get the exponent by itself. So let's add 20 to both sides and divide by 18. So that'll leave us with 1.03 power of x is equal to, see, that's 320 divided by 18. Let's try that again. So 17.7 repeating. Okay, so when we're trying to solve for x as an exponent, we use logarithms, and we developed a shortcut in an earlier chapter where we do x is equal to the log of 17.7 divided by the log of 1.03. Let's bring up the calculator and do that. So log base 10 of 17.777778 or so divided by the log of 1.03, and we get 97.36. So x in part A is approximately 97.36. Okay, moving along to B. Alright, when I'm adding logs together, we have a shortcut rule. This will be the same as log base 2 of 5x equals 3. So we can rearrange this. 2 is the base. 2 to the power of 3 is equal to 5x. So 2 to the third is 8. Divide by 5 on both sides, and x is 8/5. Alright, part C. We want to divide both sides by 8 to begin with, so we'll get x to the 2.7 power is equal to 20. And now we can do the 2.7 root of each side, or a little bit better notation wise is to raise each side to 1 over 2.7. So let's try that in the calculator. 20 to the power of 1 over 2.7. And we get 3.33 when rounded. So approximately 3.33. And for our final one, D, we've got log base 3 minus another log base 3. So using our log laws, I can put this together as log base 3 of x plus 5 divided by x minus 1 equals 1. So when I rewrite this as an exponent, I've got 3 to the power of 1 equals x plus 5 over x minus 1. 3 to the power 1, yes, is 3. So how about we multiply both sides by x minus 1. Distribute the 3. 3x minus 3 equals x plus 5. Now it's simple algebra. 2x equals 8, and x is 4. Done. And moving on to our final question. Okay, this one is a piecewise function. And when I take a look at this graph, basically I've got three pieces. This part shows it being less than -1. So I'm going to put some dashed lines on here. They're not asymptotes, they're just markers for me at -1 and here at +1, showing where the graph goes. Okay, so I know that a cubic moved down 4, so that's going to sort of trace out like this, but this part does not exist. This part does not exist until we go below here, so this part exists. Now we have a linear in between. Over here we have a x to the power of 2, a parabola that's moved down to 8. So that parabola would have a vertex here at -8, and it's something like this. So the only part that exists is over here. Now the question is, what line will make this continuous? So I need something that's going to connect here to here. So basically I need to know exactly what is this spot and exactly what is this spot. Well, we can solve for that algebraically. We're looking for what makes this equal -1. So let's solve. So x cubed minus 4 equals -1. Add 4 to both sides. X cubed equals 3. So we're looking for the cube root of 3. It's this value here. Oops, I've got my x's and y's mixed up. Alright. Scratch that. This picture's fine, but my error was in making the -1 a y. The -1 is actually our x value, so we want to find out what y is when this is 1. So -1 cubed minus 4. Our output here is -5. So this is the point. -1, -5. And for this point, +1, +1 squared minus 8, our output is -7. So I don't even have the slope of my line right. This one's actually supposed to be lower. I was just estimating there, well, it didn't work out. So anyway, this point right here is 1 and -7. So I need to figure out what is the line, the slope, and the y-intercept between these 2 points. So I'm going to adjust my picture a little bit and move this down where it should be. This is 5 and this is -7. It'll look a little bit more like this. And so I know I have a negative slope. And so sketch a little slope triangle here. I know I go down 2 and over 2. So my slope -1. And my intercept will be halfway between the -5 and the -7, so I think my intercept's -6. So you can sort of see that from the picture. It's a pretty bad picture, but it works. So the equation of this line, the a value should be -1, and the b value -6. Make this a continuous graph. Okay, what a mess, but it works. And we're done.